Hello, welcome back to our discussions of the CST 105 Milestone project. This time we're going to discuss Milestone 2, which is going to be about object-oriented design and the abstract data type. So recall in Milestone 1 we did a flowchart, so that gave you a chance to start thinking about and documenting your code for the UNO game. Keep refining this flowchart. A good flowchart will help you develop the code, and the final Milestone project will include a refined flowchart. We also did a storyboard for Milestone 1, and that gave you a chance to start thinking about how the user interface will look for your UNO game. So Milestone 2 is another planning document, like Milestone 1, except the planning is going to be about class design, and it's going to use an abstract data type. For our purposes, we can think about Milestone 2 abstract data type document as a source for Milestone 3 UML document. Milestone 2 and Milestone 3 are really closely related, and we're going to look at the assignment for both of these this time. So the abstract data type is a precursor to the object-oriented design language, universal modeling language. So it's not really an object-oriented design language itself, the abstract data type, but it's an evolutionary step toward that. Let's talk about it a little bit, the ADT. The ADT is an abstract data type, is a type that defines operation, but it does not define implementation. So at this level, you're thinking about how the data type looks from the external world and not about its internal implementation. For example, if you consider integers as an ADT, we define an integers as a set of values, the counting numbers, whole numbers, from a negative range to a positive range. Then we define a set of operations: addition, subtraction, multiplication, division, modulo, together with greater than, less than, and comparison operators like that. What can you do to this data type? This is independent of how integers are represented internally in the computer. So we're thinking about addition and subtraction. We're not thinking about how the bits change in the CPU when we talk about that data type typically. So when you use data types in software typically, you're typically addressing them as a programmer from the ADT level. At the margins, you'll need to understand the implementation, that is, what happens when you get to max int and you add 1 to it, for example. Then it helps to understand what's going to happen, to understand something about the implementation. So that at the margins you do. But for the most part in day-to-day work, we think about our data types in terms of ADTs. So I have the Milestone 2 documentation up here, and I also have the Milestone 3 documentation over here. We're going to go over both. Like I said, Milestone 2 and Milestone 3 are closely related to one another. So the goal of this milestone is to identify the objects needed for the UNO card game. And I wish it said classes here rather than objects. But we'll just ignore that for now. For example, a standard UNO card must be able to report both its color and value. And when given another card, we need to tell whether or not it's a match. So the UNO card, think about that as an abstract data type, the card. The card is going to have a set of operations and characteristics. What are the characteristics of a UNO card? Its color and its value. What are some actions or not? Whether or not it's a match. For example, the top card. Does this card match the top card? And that has various rules. Again, we're not thinking about the rules necessarily and how the code would implement those rules. We're thinking about what this looks like from the outside. A card has a color and a value. And let's say it has a method to say is match, to say whether or not it matches the top card. So we're going to review the rubric. In a bit, I'll pull up LoudCloud and we'll look at the rubric. So we're going to prepare a document, the ADT, and there's no formalized, I couldn't find a formalized way of expressing an ADT. That's different from the universal modeling language. That's a modeling language that's formalized and that we'll do for Milestone 3. The ADT is pretty much a list of, let's say, a description of the data type and the actions and the properties of that data type without a formalized way of expressing it. So we'll just use a Word document for that. Okay, so partial ADT for the Uno card class, for example. Some of this plus actually comes from UML. That means public. I don't think it really belongs here, by the way, but the majority of this is I think correct. Get color, get value, set value, and then is a match. At this point, you should start thinking about other characteristics a card might have. Well, we've described the Uno card class. So let's think a little bit about object-oriented design. When you design a class in an object-oriented language, you express that in terms of a noun. And then the properties, the characteristics of the noun are expressed there, color, value. And then the actions, those are normally expressed as verbs. The actions, the methods that the class has contained within it is normally expressed in terms of verbs. So you have nouns, and then properties within the nouns expressed in terms of verbs. What can that thing do? And what are the characteristics of it? Let's look now at Milestone 3 documentation. So Milestone 3, this is part of it's about the UML. Create a UML diagram to write the code for object classes in Uno game. So you need a minimum of 3 classes. A card class, a hand class, and a deck class. Now you see the way that Milestone 3 relates to Milestone 2. They're explicitly saying here in Milestone 3 what the classes should be. They're the same. The card, the hand, and the deck. And all of these are modeling something in the real world. Object-oriented programming languages are an attempt to get software to model objects in the real world. So now start thinking about what a card, we've already gone over what a card does, in part, but what does a hand do? Think about that. It's either a hand or a player. That has a set of characteristics. Let's say the cards inside the hand. But then also, what does the hand do? It plays the game. It's really the player, right? So it looks for a matching card. So it could use, let's say the card classes method is match, to iterate through the cards in the hand to say which one of these cards are matches to the top card. So that we can see that as the program takes shape, it's a set of classes that are working together to form a program. Each class minding its own business, having its own set of properties and actions. That's getting into object-oriented programming language and design. We also have the deck class here, and think about the characteristics of that. The cards that are in the deck and the actions that the deck can do. Well, the deck can deal and the hand can receive. So you think of dealing in the initial part of the game, the deck class is involved and the hand class is involved. There's some other objects involved in here. Now, I like to set objects, right? Because the discard pile exists in the Uno game. Is that a class? Or is that another instance of the deck class, right? So that you have the deck, which is a deck, and let's say the discard pile, which is also, let's say, categorized as a deck class. You can implement that the way you want, because you can also have very easily a discard class that's related to the deck class. I would think you would also want a game class that actually expresses a very simple method from the outside, play. The game has a play method, and maybe that's its only method. It's not a simple method, it's probably the most complicated method in this project, but it has a single method. Okay, we'll discuss more about Milestone 3 when it comes up. But I wanted you to notice the relationship between Milestone 3 and Milestone 2. They fit together. Now we'll take a look at the Milestone 2 rubric. So we'll go right to what is an excellent or 100%. So a robust set of objects that are identified as a Uno card game. So the card, the hand, the deck, and their characteristics. So their methods, what can you do to those? Think about the abstract data type again of integer. What can you do to it? That's what we're really getting at. So if this project was described the abstract data type for an integer, you'd say add, subtract, multiply, divide, etc., and the comparison operators. For this, you want to identify the classes that are involved in the Uno game, and then the methods of those classes. What can they do? And for this, I think it helps to imagine an Uno game being played. What happens at each turn? What happens at the deal? What happens when a player calls Uno? What happens when a player wins? What characteristics happen then, right? All of those things have actions in the game. What happens when a wild card is played? A wild draw 4 is played. A skip card is played. All of those things have actions that are represented in methods within, let's say, the card class or the hand class or the deck class. Do that and you'll have a robust set of Uno games. Then you have good explanations. You have a concise and precise explanation. Covered all the requested material. And you've defined every class that's present in the correct format. Okay, so I don't think the ADT really has a formalized format that I could find. Just a nice Word document with a list of let's say the classes at the top and the actions underneath, and then a short description of the actions or the methods that class has. All right. So I think that concludes our introduction to Milestone 2. Thank you.